Hello, Mr. Stone here. Today we are going to take it to the next level. We are going to set up some systems of equations involving three variables, and we're going to solve for them. And you're like, whoa, what is this? Well, we've got a third variable here. This is z, right? Okay, it's just one more that we can do, but here's the thing. We've got three variables, therefore we need three equations to solve them. We've got two methods of doing this. We can do the elimination method and we can do the substitution method. Now the elimination method we've already worked with, and the substitution method as well. But we've done it with three variables, or two variables, excuse me. Let's do it with three. Really, the way to do that is to figure out how you can knock out using one of these guys to knock out one of the variables from the other two. Okay? So I think in this case, I see I've got just an x right there, and in the past we've seen that if you've just got a variable by itself, it tends to be a little bit easier to work with as far as if we're manipulating, if we're trying to cancel some out. So here's my objective. I'm going to use elimination to solve for these. I want to eliminate the x. I'm going to try to eliminate it from both the second equation, equation number 2 here, and the third equation as well. Alright, let's see how that works. So I've got my first equation. The first two I can just combine, right? X minus 5y plus 3z is going to equal 3. Then I've got negative x minus 3y plus 4z equals 6. Combine. Together these are 0. I've got negative 8y. I've got plus 7z. Combine these, I've got 9. Okay, and this 0 is just really not there. So now I've got negative 8y plus 7z. That's what I want. Okay, so over here I'm gonna leave this. I can't do anything more with this right now. We're gonna see where this is going. So I'm gonna tuck that guy away. I'm gonna put him over there for safe storage. Now I'm gonna take, let's call this first one number 1, 2, and 3, or A, B, C, I suppose we could do, but well. Let's combine the top one with the bottom one. But I need to multiply that top one in order to make it all the x's cancel in the last one. So I am gonna have let me move it down a little bit here. I am gonna be working with x minus 5y plus 3z would equal 3, but I want to multiply everything on both sides here. And since I've got a 3 over here and negative 3, I'm going to want a positive 3 over here, which means I need to multiply the x by 3 and therefore everything by 3 in order to keep it even, just like we were doing when we had two variables, okay? This isn't anything really new. This is just a slight extension of what we were doing before. So distribute 3 times x, 3x. 3 times negative 5, negative 15y. 3 times 3z comes positive 9z equals 3 times 3, 9. Okay. I'm going to bring that over here. I'm going to just take what I just figured out from how we manipulated that first equation. Equation number 1. Oh, I might sneeze here. Oh boy. I'll try and shield it from the microphone so you don't hear it like this loud gust of wind. You know how I sneeze. Okay. So I'm going to combine these together. This is separate over here. Let's just keep them separate. These cancel each other out, so that would be 0. This negative 15y, positive 2y. Well, that's going to give me negative 13y. And then I've got a 9z plus 4z. That gives me positive 13z. And then 9 and 4 together give us 13. Okay, so I've manipulated equations number 2 and number 3 to give me negative 13y plus 13z equals 13. Now this should look pretty familiar. I mean, yes, we don't have an x, we have a z instead, but you know what? We've got 2 equations, we've got 2 variables. You have done this before. This is just what we were working on earlier, and you should have no trouble with this. Okay? Don't let the fact that that's a z instead of an x freak you out, because it is no big deal. That's 7. I'm just copying down. I'm just bringing this guy down so we have some clean space to work from, okay? I'm going to cut all that stuff off there just so that we're working some new space. Equals 9, negative 13y plus 13z equals 13. Okay. These are going to be a little messy. I think probably the best thing we can do here is we want to have, let's cancel out, may as well cancel out the y's. Okay, why not? Why not? Let's multiply all of this top guy up here. We're going to multiply everything up here by negative 13. Why negative 13? Because I'm going to multiply everything on the bottom, the whole thing, by 8. What this is going to give me is, if I've got 13 times 8, well, let me get my calculator out here. 13 times 8 gives me 104. So I'm just going to distribute this negative 13 and this 8, and you'll see where this is going, okay? So this now becomes 104 y. That's the first thing. I'm working on this guy up here first. Okay. Minus, well, 13 times 7. That's 91z. And 13 times 9. That's, or negative 13 times 9, this is going to be negative 117. Okay? The bottom, I've got 8 times negative 13. Hey, this is negative 104. Why? I'm multiplying these by each other, except I have to change the signs around a little bit, because that way they will cancel out exactly. If I don't have like an easy way to multiply one so I can get the other coefficient, so that they're equal, then I need to do this. It deals with a little bit bigger numbers, but it's nothing really earth-shattering. 8 times 13 gives us positive 104z. And 8 times 13 again, that just is going to give us 104. Now I combine. Okay, again, this is pretty much the same thing you were doing the other day. Hey, my y's canceled out. Negative 91 plus 104, negative 91z plus 104z. Hey, that gives us 13z. And negative 117 plus 104. Hey, this equals negative 13z. I can divide now both sides by negative 13, or excuse me, by positive 13. 13, positive 13. I get z equals negative 1. There's part 1. I can go back to one of these guys from up here. Let's do this one. Let's do negative 8y plus 7. I'm going to plug in for z. 7 times negative 1 equals 9. Okay, let me cut this guy off here. That means negative 8y minus 7 equals 9. There's y. I add 7 to both sides. I get negative 8y equals 16. Divide by negative 8. And then I get y equals what? Y equals negative 2. my second part of the equation, or excuse me, of the solution. So I've got z equals negative 1, y equals negative 2. Let's go back into this very first equation. We can plug it in here. If we've got y is negative 2, we're going to plug in negative 2 there. We're going to plug in negative 1 here. So, I'm running out of space. Let me go over here. Okay, I'm going to have x plus 10, because I'm distributing this. That's 10. 3 times negative 1 minus 3 equals 3. So I get x plus 7 equals 3. Subtract 7 from both sides, x equals negative 4. So my final answer is going to be negative 4, negative 2, negative 1. Or I can say x equals negative 4, y equals negative 2, z equals negative 1. Okay, so now we're going to look at the substitution method. I've got this first equation up here, which I'm really going to be using a lot of, because I can put everything in this first equation in terms of x. Notice how we've already got z defined as negative 3x plus 12, and we've got 3y equals negative x. Well, you know what? Let's rewrite this 3y, and we're going to make this, we're going to divide both sides by 3. That would just give us y equals negative 2. So right now I've got z equals negative 3x plus 12, y equals negative 2. I'm going to rewrite this whole equation in terms of just integers and x. Okay, so negative 5x comes right on down. Negative 5 times, well, we already said it would be y, but we already said y is negative 2, so let's plug in negative 2 right there. Okay, substitution, so we're plugging in things of equal value. Plus 3z, 3. I'm not going to put z, I'm going to put what z is equivalent to, which is this negative 3x plus 12. Okay, and all this is equal to, and the equation says negative 10. So let's simplify this out a little bit. We kind of have a bit of a mess going on here. This is negative 5 times negative 2. We'll actually make this plus 10. And then 3 times negative 3x. So that would be minus 9x. 3 times 12, that would be plus 36. Equals negative 10. Combine like terms. We've got a negative 5x and negative 9x. That makes it negative 14x, positive 10, positive 36, so this is plus 46 equals negative 10. Now I need to get rid of this 46, get it over here, cancel. I have negative 14x equals negative 56. And now I need to divide by negative 14, so I get x by itself. That cancels. I get x equals, well, this is just 4. 4 times negative 14 will give you negative 56. So now I know that x equals 4. Y, we already said going back up here, that turned out really nice, that y equals negative 2. So y equals negative 2, and our z is equal to negative 3x plus 12. So plugging in, now that we know that x is 4, we can say that z is equal to negative 3 times 4 plus 12. Well, negative 3 times 4, that is just 0. Oh, excuse me, I'm getting ahead of myself here. Negative 12 plus 12, and so the whole thing is equal to 0. So z equals 0. Does that mean that z equals 0? There's our answer, or we write it as a coordinate for a point, which is nice and tidy, as so. Okay? Substitution is a bit more complicated, I think, than the elimination method, but sometimes it still is the best choice. I'd like you to practice a little bit with that one, in addition to the elimination, and we'll talk more about that in class. So